Hi, this is Jan from Terra3D. In this video, I'm going to show you how to use the fully automated wire modeling module from the Terra3D Rail software suite. Let's start. In the install directory, I open the folder called bin. This is where the main executable file is located for those that want to run it through the command line interface. But in this video, I am going to concentrate on the graphical user interface mode. So I launch GUI.x, which is located in the GUI directory. I want to export 3D models from 3 LAS files that are in the following folder on my desktop. This is why I select the full directory as input. I could also have selected individual LAS or LAS files as input with the field on the right-hand side of the window. I select the output directory and set the desired file name. Then I will provide the trajectory of the train corresponding to the lane I want to vectorize. Indeed, this program is designed for clouds coming from a mobile mapping system. The trajectory should look like this. It is an ASCII file where each line describes a point and contains a GPS time, coordinates and orientation. To specify the expected trajectory format, I click on Configure. In the new window, I specify the coordinates format, XYZ, east, north, up, or GPS coordinates. I also specify the unit for orientation angles, degrees or radians. I can then specify the number of lines to skip, corresponding to the number of lines in the header, and the position of various informations on each line of the file, time, x, y, z, pitch, roll and heading. To help the program localize the catenary wire, I will provide a prior estimation of the transformation from the trajectory to cable. This transformation is specified through a config file containing 2 values of translation, one towards left and one towards up. Be reassured, there is no particular need for these values to be precise, especially as we know that the wire altitude is not constant along the lane. Providing a transformation 1 meter away from the actual value is precise enough. In this example, I know that the cable is approximately 2.4 meters above the trajectory. On the bottom of the window, there are a few more parameters I will set. First, there is a switch to choose if I want the result to be exported as a single connected polyline or if I want the output model to be split each time there is a change of contact wire. I let this switch off. Then I set the step in meters between the vertices in the final polyline. For example, I will ask to get 1 vertex every 3 meters. Then there is a switch to select if I want the program to export debug by products. I will explain later what these debug images are. And finally, I need to specify the EPSG index corresponding to the input files. When everything is set up, I simply click on Launch Process. The program opens a console. It will read the trajectory and sequentially perform the extraction for all the input point clouds. You can see the progress in the console. When the process is over, the program exports the 3D polyline to the selected path. As I decided to export the debug images, the program created a directory for each processed file. This directory contains images one can use to inspect the results. They represent slices taken along the cloud. 1 slice per polyline vertex. In these images, the trajectory is displayed with the large green target, the prior estimation with the small green target, and the final vertex position with the small red target. You can check that the polyline is perfectly aligned with the catenary wire. The program also exported some georeferenced rasters where you can visualize the polyline and localize the aforementioned slices. The color map depicts some performance metrics. As a result, it only takes a glance to check the quality of exported models. To visualize the result, I will open a cloud with an open-source software called Cloud Compare. You can see that the vector in red is perfectly positioned on the cloud. And that's it. The 3D polyline can now be used to create or update a GIS database. Or perform some asset management tasks such as geometrical regulatory checks. This is Jan from Terra3D. Thanks for watching. Don't hesitate to contact us to get your trial license.